llama.cpp B105002 adds an attestation, a release-linked record meant to help check signed download files outside the release page. Download a ready-made llama.cpp package, and you now get a linked record to check. The file name is no longer your only signal. This is not a speed update. Inference means running a model. B105002 claims neither faster inference nor better model output. GitHub records B105002 on August 19th at 13:26. That timestamp makes this a current release change, not old guidance resurfacing. The promise is narrow. Signed artifacts are release packages handled by signing tooling. Their attestation supports checking, not a broad safety guarantee. Your practical question is simple. Does this add a step before running a download? The release, pull request, and test trail answer it. Release B105002 names one focused change: add attestation for signed release artifacts. It links that work to pull request 25933. Think of the attestation as a receipt attached to a release package. GitHubot's workflow creates it for external validation. A workflow is an automated sequence of release jobs. The contributor says GitHub's provided workflow performs the attestation and signing work. The release page links its attestations beside the downloads. That placement gives binary users a visible place to begin checking evidence. GitHub marks commit 0ADCC3B verified and shows its GPG key identifier. That identifier names the key associated with the displayed signature. You see two separate signals: a verified release commit and an artifact attestations link. Checking one should not be mistaken for the other. Contributor Quartzger proposed the change in pull request 25933. The work later entered the main code branch, called master. CISC approved the changes and applied merge ready, meaning the review considered them final enough to merge. Then Girganov merged the commit. The next concept is the release matrix, the full menu of packages for different systems. Attestation does not make that menu simpler. Suppose you need a Windows CUDA package. CUDA is one accelerator option named by the release, and selection comes before checking evidence. An artifact is the file you fetch. Here, artifacts are packages for macOS, Linux, Android, Windows, OpenWoiler, and the UI. Signing tooling adds the identity evidence described by the pull request. The packet gives no deeper cryptographic details, so the claim stops there. External validation means checking linked evidence beyond the release own wording. That is the contributor's stated purpose for these attestations. Previously, a familiar file name could look official by itself. Now builders can also ask whether the release exposes its stated validation evidence. A backend is a package choice for a particular execution system. Attestation cannot decide which backend fits your machine. A Linux builder still chooses a processor family and acceleration option first. That hardware fit decision comes before using the validation record. The release marks certain macOS, Ubuntu, and OpenWoiler variants disabled. Disabled means not available here, and attestation does not enable them. Use this order. Choose the listed build that fits your system, then open the release attestation. That is the new practical workflow. The pull request also records how the change was tested. That trail includes a fork run, exceptions, review, and the final merge. A fork run is a test on the contributor.s repository copy. CISC requested one and allowed some components to remain disabled. Quartzger reported that the forkie's release attestation step succeeded. Practically, this is the packet's direct test result for the new feature. The overall run was still red. SYCL, one listed backend, and Hugging Face UI publishing failed. The contributor called both unrelated to attestation. A red workflow can contain a successful step. Here, the useful detail is the reported attestation success, not the dashboard's overall color. The fork skipped S390X, a processor family label listed for Ubuntu. So that run cannot demonstrate the attestation path for every processor family. It also skipped deploy key checkout, the job that fetches code using that key. Therefore, not every release job completed. After seeing the fork results, CISC accepted the evidence and marked the change merge ready. That moved the tested work toward release. GitHub records Jurganov merging commit 0ADCC3B with 4 checks passed. Those 4 checks supported the merge despite the separate red fork run. The proposal began July 20th and merged August 19th after a rebase and test. That month-long trail shows review, not an overnight change. The recorded sequence is proposal, review, rebase, fork test, approval, then merge. Each step explains how the change reached the release. The release exposes 27 assets, meaning 27 downloadable entries. That number increases package selection work before attestation becomes useful. Those downloads cover macOS, iOS, Linux, Android, Windows, OpenELR, and UI assets. Your operating system narrows the shelf first. On macOS, ARM64 and x64 identify processor families. Choose Apple Silicon or Intel accordingly. The extra listed ARM64 variant is disabled. Ubuntu adds several accelerator backends, meaning compute system package choices: Vulkan, ROCm, OpenVINO, and SYCL, alongside 3 CPU architectures. SYCL offers FP32 and FP16 packages. Those labels name 2 numerical precision formats, so SYCL users must choose the listed format too. Windows has the longest menu: CPU, CUDA, Vulkan, OpenVINO, SYCL, and ROCm across x64 and ARM64. Hardware fit remains your decision. The CUDA packages name their DLL versions, meaning Windows Support Library versions. CUDA 12 lists 12.4, CUDA 13 lists 13.3. The Windows ARM64 CUDA 13 package lists CUDA 13.4 DLLs and carries a preview label. Attestation does not remove that caution. Android has one listed package: ARM64 CPU. One option means less selection work than Windows or Linux, but validation still follows selection. All 4 listed OpenELR packages are disabled across 2 processor family groups. Practically, attestation makes none of them available. So one attestation headline sits beside 27 assets. For builders, that means identifying one exact package before its evidence is useful. The sources establish signing tooling, attestation, external validation, testing, and merge history. They do not establish universal security for every download. Neither verified page claims malware detection, binary content auditing, or guaranteed clean machines. Do not treat the attestation as any of those checks. Tokens per second means how quickly a model produces text. B10FIV02 reports no speed, wait time, memory, or model quality improvement. Compatibility means whether a package fits your setup. A validated Windows CUDA artifact can still be the wrong architecture or backend. The Windows ARM64 CUDA 13 package remains preview. Keep that label in your decision. Attestation changes evidence, not release status. The disabled macOS, Ubuntu ROCm, and OpenELR entries remain unavailable. Validation evidence and package availability are separate decisions. The fork also skipped Windows ROCm, one listed backend. Combined with the other skips, that prevents an all-platform test claim. Use this exact scope. The release adds attestation for signed artifacts intended for external validation. Stronger wording would exceed the contributor's claim. The downloads are more verifiable because the release exposes additional validation evidence. That improves the checking workflow without promising universal safety. If you use llama.cpp release binaries, add one action. Check the attestation after choosing the package that fits your machine. Begin on the versioned B105002 release page. It puts the commit status, attestation link, platform list, and downloads in one place. First match 3 things: operating system, processor architecture, and backend. That prevents checking evidence for a package your machine cannot use. Next, preserve every status label. Disabled stays unavailable, and preview stays preview. Attestation is evidence, not permission to ignore either. Then open the attestations page linked from B1052. That direct link is the new builder-facing path added by this release. Read that record narrowly. It is evidence intended for external validation of signed artifacts. It adds no performance or compatibility promise. The verdict is modest. B1002 makes release downloads more verifiable. Speed, model quality, compatibility, and availability sit outside that improvement. For future releases, check whether attestations remain visible as package lists change. Also recheck which builds are enabled, disabled, or preview. This is not faster local AI. It is a better documented download check. Use that receipt and keep the same skepticism about broader claims.